Today, on how it's made. Firefighter helmets. Letting cooler heads prevail. Nautical compasses. It's a voyage of discovery as we tell you how they make them. Packaging tubes. We put the squeeze on a factory to let us inside. And hand saws. This story has an edge to it. In the early 1800s, luggage maker Henry Gratacap created one of the first firefighter hats. The leather helmet had a long rear brim and curved sides as a shield against falling debris and water running down the neck. Except for a few high-tech additions, this basic design is still used today. Leather is surprisingly flame-resistant. When reinforced, it also becomes a remarkable hard hat, protecting from heat, liquids, and sudden impact. On this newer model, the accessories shield the eyes and ears too. A helmet starts with 4 die-cut leather sections. They sew them together to make what's called the skull of the helmet. This piece will become the brim of the helmet. To give the skull structure, a worker folds and sews each section, then flattens the crease with a special hammer. He uses a template to score a sewing line in the leather. Then he uses a powerful sewing machine to join the sections together. He now joins the 2 halves together, reinforcing them with double stitching. The resulting 8 ridges give the skull stiffness and strength. He stretches the leather over a plastic mold and trims excess leather from the ridges. Then he clamps 4 vice grips to the rim. These attach to a hydraulic jack that stretches the skull overnight. After applying glue to the ridges, he runs them through compression rollers for a tight bond. They wet the brim piece several times to make it more pliable. Then they stamp it with a design used by this company since 1846. But first, a worker inserts a wire that will give the brim some structural support. Then, a temporary plastic cover and a lid to ensure an even spread of pressure across the brim. She stuffs the edges of the leather inside before the press applies 10 tons of force to imprint the design. Next, a worker sews the skull to the brim. He removes the excess leather at the base of the skull and cuts out the center of the brim. Then he removes the plastic mold. To seal the leather, they dip the hats in a vat of hot rosin, a type of tree sap. After 55 minutes, they remove them and let them dry at room temperature for 8 weeks. This slow-drying process makes the leather about as hard as wood. Drying it mechanically would make it brittle. Now for the inside. They insert a plastic cap to reinforce the structure. The fit is intentionally tight, so they use a mallet to tap it into place. Inside that, they add another plastic cap with nylon straps to resist the impact of falling objects. Here, a worker uses an acetylene torch to burn off any loose threads and soften the leather in order to bend the brim and straighten the ridges later on. Turning up the sides is basically for aesthetics, but the longer edge in the back is to direct water away from the neck. After adding a synthetic fire retardant liner, He sands the outer surface to prep it for painting. First, a fire-retardant chemical primer. Then they use a semi-gloss latex paint in Firefighter's black or white for the chief. Or if you prefer, a clear varnish to show off the natural leather. Add a front piece with the Firefighter's signature brass eagle on top and some fluorescent stickers for extra visibility. And you've got the right headgear for a hero's job. For more than 1,700 years, the compass has been helping people find their way. It was first developed in China, and eventually, East met West. And European sailors began using it to chart their course. They soon realized they'd be lost without it. To make a nautical compass, they use this device to magnetize a special metal alloy. A technician slips a retainer ring onto a jig and positions the magnet on top of it. She places an aluminum skirt over the magnet. This will support the compass dial, which goes on next. She inserts a pivot needle in the center, which will allow the dial to rotate. Then she press fits all the pieces together. She carefully inspects the fit, and it looks solid. She sprays a chemical cleaner into the pivot cavity. It has to be spotless because any dirt would impede its function. She also cleans a little jewel post that contains a tiny sapphire. Then she fixes the jewel post in the dial. The jewel post will support the dial while allowing the pivot needle to move easily as it's pulled by magnetic forces. She places the dial on a machine that mimics the Earth's pull. It's a crucial step because magnetic force varies depending on where you are in the world. She brushes a weighted paint on the back of the dial to counteract the pull. This balances the compass dial, preventing false readings due to differences in the planet's magnetic force. These are lubber lines, little direction markers. She inserts them into holes in a jig. Then she lines them up with holes in an aluminum gimbal pan and press fits the lubber lines to the pan. Now she inserts 2 pins into the gimbal ring that allow the ring to flip around the gimbal pan. Then she attaches the compass dial to the gimbal assembly. The technician spray paints the metal compass bowl black and pops a rubber diaphragm into it. A bronze ring will hold it in place. This flexible rubber liner will contain the compass fluid and allow it to expand and contract. She snaps the dial and gimbal setup to the bowl. She just has to bend a little tab to level it out. She positions an acrylic dome on top. Using another jig, she puts a rubber O-ring over the dome to seal it, followed by a metal collar. With a power screwdriver, she anchors these pieces to the rest of the compass. Then she pumps fluid into the bowl, filling it almost to the top. The fluid makes the numbers on the dial look bigger. Next, they magnetically charge 2 metal rods and install them in a compass base. They'll compensate for magnetic fields on the boat. She mounts a big metal housing unit on the base. Then she attaches shock absorbers to cushion the compass against engine vibrations. She installs the compass in the housing and taps the dome to test the shocks. A decorative aluminum cover fits around the dome. Then she installs a light to allow the navigator to see at night. She attaches iron spheres, another tactic to counter magnetic interference. Our journey through the plant is now over, and the compass is ready to set sail. Artists first used flexible metal containers for their paints back in 1841. Nowadays, we use them for a range of gooey things like toothpaste, glue, and skin cream. The tube's design lets us squeeze out most of the product and yet still read that important fine print on the twisted package. These packaging tubes are made of aluminum because it's affordable, lightweight, and malleable. This company makes each tube from an aluminum slug about the size of a coin. A worker dumps a batch of slugs in a container, then adds a lubricating powder called zinc stearate. The container spins, causing the powder to coat the slugs evenly and prep the metal for stretching later on. The slugs then spin around in another container, which orients them horizontally, so they'll fit through a channel at the bottom. The channel feeds the slugs into a forming press. In a process called impact extrusion, each slug moves onto a die which gives it the exterior shape of a tube, including the neck. At the same time, a mandrel forms the interior. This process hardens the metal, something they'll correct later on by heating it. The machine applies 200 tons of pressure to as many as 150 slugs per minute. They can be as narrow as 1 centimeter and as long as 22 centimeters. This machine uses compressed air to align the tubes for the next step. A trimming machine cuts threads into the necks by passing each one between 2 synchronized rollers. Stationary blades trim the top of the neck, making the surface smooth and safe to handle. The neck on most models remains sealed until the consumer pierces it. Another company eventually seals the tube by rolling up the other end after they've inserted their product. After heating them to soften the metal, the tubes move through another machine. Here, nozzles spray the insides with 2 coats of epoxy lacquer. This creates a protective barrier between the aluminum and the eventual contents. Rollers apply a coat of polyester enamel paint, which is flexible when dry and resistant to most solvents and sun damage. Grippers place the tubes on long pins, which move them through an oven for 7 minutes so the paint can dry. From there, it's off to the printing machine. Each tube makes 1 complete rotation against a printing plate. The plate applies a colored image and information that describes the tube's contents. Then they go back in the oven to dry the ink. The printing's legible even when twisted because the polyester ink remains flexible. Another machine applies a kilo of torque to screw on the plastic caps. Most of the caps have pointy tops used to pierce the sealed neck of the tube. They use flat caps to close off tubes with open necks. On the next machine, nozzles spray on a strip of latex sealant inside the open end of the tube. The latex is like a gasket. After the product is inserted, it seals the tube when they fold the end over. After a machine packs boxes with an average of 300 tubes each, A worker inspects the inside of every tube. A bright spotlight reveals any chip in the paint that makes the packaging deficient. About 1 in every 500 tubes is flawed. A sheet of sticky paper over the open ends of the tubes keeps them from twisting during shipping. And a label on the box provides tracking information and a way to show if someone has tampered with it en route. Empty, each tube sells for about 12 cents each. Not bad for something designed to be your main squeeze. Invented thousands of years ago, the handsaw continues to make the cut. You'll find it at every building site, always at the ready. Power tools are higher tech, but the handsaw has a basic appeal. It doesn't need an extension cord and almost never breaks down. It's a trusty tool with the teeth for the job. Handsaws come in many sizes. To make them, a machine uncoils steel and draws it into a mechanized punch. The punch works at a blurring speed to cut teeth in the steel, 140 notches per minute. Here it is in slow motion. It makes 2 cuts for each sawtooth. A reel takes up the newly serrated steel and then will feed it back to cut teeth on the other side. Next, a finger-like device unrolls the steel and pushes it to automated jaws. The jaws bend the teeth, alternating the direction of each one. Here's a slow-motion look. This is called setting the teeth, and it will allow the handsaw to operate smoothly. Now a die punch cuts the steel coil into pieces called double blanks. Double because 2 saw blades will be made from them. The die also makes holes in one end of the double blank for attaching handles. They feed the double blanks to a shear machine. A long blade descends and cuts it in half on the diagonal, making 2 saw blades. Finally, they press the saw blades up against a sand belt to smooth out the edges. This is called deburring. Here they're making a higher-end saw blade. They flush a piece of steel with coolant as a machine plunge grinds it to make teeth. This method is more time-consuming, but results in a superior tool. Again, they set the teeth. But this time, mechanical jaws do the job, a blade at a time, rather than working on one long coil of steel. The saw teeth will need to be strengthened in order to perform. So rollers move the blades to an electrical coil. Within milliseconds, the temperature of the blade shoots up to almost 900 degrees Celsius. This tempers the steel. The blades drop off the conveyor into a bin. Here's a look at a blade before heat treating, and this is after. The black burn line is a sign this saw can take the pressure. A conveyor wheel dunks them in a pool of clear protectant. This will keep them looking shiny. When they're dry, the blades undergo a trademark technique. They place one on a table. It rises, and a squeegee silk screens the company name onto it. At this point, the ink is still wet. They spend 30 seconds in an infrared oven, enough time to bake on the brand name. They slide cardboard sleeves over the blades. And now it's time to get a grip. A worker fits two plastic handle parts together and places them on a carousel. An ultrasonic sealer moves in. It emits a high-frequency sound, and the vibrations melt the two plastic pieces together, forming a handle. A worker fits the handle onto a blade, and a machine rivets it in place. Some saws have wooden handles. Because riveting could split the wood, they bolt it on with screws and riv nuts. And now, you have tools that are cut out for the job.